AMD today announced 3 new GPUs, the 6800, 6800 XT, and 6900 XT, and announced the specs, pricing, and additional features and some light architectural information for those GPUs and for the RDNA2 architecture, which is an iteration on, of course, RDNA not 2, 1. The company also endeavored to suggest some interesting implications for its new GPU launch. Namely, it's saying that combining a Ryzen 5000 series CPU with an RX 6000 series GPU and a 500 series motherboard will provide additional performance uplift. So we're going to be talking about that information today. So far, this is an announcement piece, so AMD has not disclosed full details on the architecture yet, although it is planning to do so soon, and we obviously don't have cards in hand to provide any form of third-party validation of the data. But we can still talk about the primary announcements, some of the light architecture details, and the product details. Before that, this video is brought to you by Thermal Grizzly's Conductonaut liquid metal. Conductonaut is what we've used in all of our liquid metal and delid thermal tests, capable of dropping CPU thermals significantly when replacing the stock thermal interface. Lower CPU thermals don't just allow better overclocks, but also lower noise levels because the transfer efficiency is increased. The mix of gallium and indium makes for a thermal conductivity of 73 watts per meter Kelvin, outclassing traditional pastes significantly. Learn more at the link in the description below. So to get some of the basics out of the way first, just to bring everyone up to speed, the stack of GPUs from AMD is intended to compete with the 30 series GPUs in a fairly straightforward way. 6800 is supposed to compete with the 3070, although at the time AMD was working on its first-party benchmarks, the 3070 wasn't out yet, so they used the 2080 Ti, but roughly the same performance anyway if you saw our 3070 review. The 6800 XT is intended to compete directly with the 3080, and then the 6900 XT is intended to compete somewhat directly, although the memory capacity difference will matter for 3D artists, but in gaming at least somewhat directly with the 3090. For ray tracing, this is also going to be a major news item today, where AMD now has included ray tracing hardware, physical hardware, on the GPUs that will handle ray tracing intersection calculation within BVH, and this will lean on DXR compatibility. DXR is the backbone to what NVIDIA has modified and rebranded as RTX. So we'll be talking about that too. But the status of AMD's drivers is also up for discussion, overclocking capabilities, a couple of other things, and then of course some discussion on the market positioning of these cards. Let's start right away with the specs for the 3 GPUs, and then we'll get into some of the deeper initial details to the extent of depth that AMD provided. AMD will have a separate Architecture Day event. These are typically hosted by the 3 big silicon companies, where they'll spend a day informing the media on actual information. It's not marketing stuff. It's normally an architect or a PM or someone of that nature providing information at a product level, cooler, GPU architecture, all that stuff. So that'll be a separate thing, and we'll describe more of the overhaul and some of the keywords here today that we're being introduced to. So AMD's architecture, first of all, is defined differently from NVIDIA's. When you see CUs and SMs and streaming processors and CUDA cores, those things can't necessarily be linearly compared, and certainly not for how they react in a gaming environment once you have all of the components put together into one GPU. So the RX 6800 XT is, again, the 3080 competitor, and thus, in our view, the gaming flagship. It runs 72 CUs. The 6900 XT is more of a 3090 counterpart, again, with less memory and less of a gaming improvement than you'd see in the 68 or 68 XT, similar to what we saw with the 3090 and 3080. This increases the CU count by 8. And then we've also requested a block diagram and a white paper, but because we haven't been given one yet, we're not sure of how much additional room there is, if any at all, for a GPU to slot in above one of these or between them. We'd assume that there's at least some room above it, but we're not sure to what extent. The 6800 stops at 60 CUs. Although AMD didn't formally tell us this, our present understanding is that the streaming processor count is still 64 per CU. So if that holds true, that would put these at 3840, 4608, and 5120 from low to high end. AMD is still trying to make game clocks a thing, presumably just like its later redacted game cache, and said that these cards will run at 1815 megahertz to 2015, depending on the model. It claims that it will boost up to 2105 for the 6800 and 2250 for both XT models. If you weren't around for the last launch, maybe you skipped a generation or you're new to this, AMD introduced the game clock terminology to basically mean boost clock as it is traditionally presented. It's the aggregate clock of some unknown amount and type of games, and then boost by AMD's new definition, by normal people terms, means the peak opportunistic clock. So boost clock in AMD's spec sheet could be for a blip, for a couple milliseconds, and under optimal conditions, that would be the best thermal conditions, for example, and best load conditions. So game clock is the one you'd want to pay attention to. For the main one we'll be looking at when we're overclocking things. We're trying to increase that average baseline. As for the rest of the specs, each card runs 128 megabytes of cache and 16 gigabytes for the GDDR6 frame buffer. We were told that the memory would be entirely on one side of the PCB, so we shouldn't be seeing two-sided memory placement on any of these. AMD claims a total board power of 250 watts for the 6800 and 300 watts for the two higher-end SKUs, with launch dates of November 18th for the 6800 and for the 6800 XT, and December 8th for the 6900 XT. As for the pricing, AMD was unfortunately only willing to share every single other detail of its launch with us, except for pricing. So at time of filming this, we don't actually have the price details, but it is public. So what we're gonna do is post a comment immediately when this video goes live. It'll be the top pinned comment. It's gonna have the pricing, and it will also have our thoughts, if any are accompanied with it, on what that pricing entails. But from what we understand at the time this video is being filmed, the pricing should be fairly directly comparable to NVIDIA's pricing in at least 2 out of the 3 SKUs, and then the third one we're not quite sure where that's going to fall. But our understanding is that the 68 and 68 XT should be relatively close, plus or minus $50 from NVIDIA pricing, but we'll see if that holds. And comment in the top. Just scroll down and check that if you want to see more. So AMD directly called attention to the use of a standard 8-pin power connection. It oddly suggested that this would improve compatibility, but because NVIDIA ships with the adapter, that comment seems like a bit of a stretch. AMD does, however, have a point for the cable management, where it subtly mentioned that cable management would be standard or better with the connector located on the far side of the card, which we agree with. NVIDIA's 12-pin connector is especially weird on its RTX 3070, seeing as that's just being fed by a single 8-pin, and the single 8-pin isn't that different in size requirements from 12. Anyway, the 6800, 6800 XT, and 6900 XT will all use a 2x8 power pin setup. AMD says that the largest card will require 2.5 slot compatibility, but that it is trying to stick to 2 slot wherever possible. Moving on to the next section, this one's talking about Infinity Cache, Rage Mode, and architecture changes to the extent that we have them now, again with a deeper dive later on this channel if whenever AMD provides that. So first off, AMD hasn't gone into full details of its Infinity Cache yet. We don't know precisely what that is, so we're not exactly sure what makes it infinite, but surely we'll learn soon. We hope that the upcoming architecture details will tell us, but for now, we know that AMD is claiming a bandwidth increase on a 256-bit interface as compared to a 384-bit interface without the to-be detailed Infinity Cache equipped. So AMD says that Infinity Cache should help with, quote, minimizing DRAM bottlenecks, latency issues, and power consumption, and that it will assist with bandwidth. AMD's biggest memory subsystem change sounds like it's in the Smart Access memory, which AMD says will be afforded to owners of Ryzen 5000 CPU, 500 series board, and RX 6000 GPU. When we asked about its Smart Access memory, AMD told us the following. Quote, Smart Access memory allows the CPU to address the full amount of memory available in RX graphics. The AMD Ryzen 5000 series processors can access this memory and deliver additional levels of performance in games, end quote. AMD presented a slide that estimated a combined increase of between 2% and 8% with a 13% outlier for a combined use of both Smart Access memory and Rage Mode, but it did not disaggregate these results. Rage Mode is basically a step below Auto OC. We'll talk about that more in a moment. And after some further questions, AMD noted that Rage Mode in these slides was responsible for about 1 to 2% of the improvement. Our assumption is that the total improvement shown percentage points in that chart, with SAM, or Smart Access Memory, responsible for the rest of it. AMD also says that this is available due to changes made for console hardware, and it warns that the technology will be highly game dependent, as shown in that slide. AMD also said that the benefit will be greater at 4K and 1440p, and less present at 1080p or lower resolutions. We asked whether the chart was created using a normalized platform, in other words, 5000 CPU, 500 board, and then whichever GPU they're showing with the feature just toggled on and off, so not changing the CPU. In other words, the answer was yes. Testing was conducted with the same everything, and that's shown in the end notes of the presentation as well, just with SAM and rage mode enabled versus disabled. So speaking of rage mode, we spent some time, that name is weird to say. We spent some time talking with AMD about it. It sounds like a throwback to the old rage stuff. The company noted that, quote, rage mode basically increases the power slider for the card. So it'd be similar to sliding the power slider in Wattman or Afterburner, Precision if you use NVIDIA, whatever, slightly to the right. Rage mode does not completely max out the slider. It keeps it within whatever the card's defined capabilities are, or optimal operation, or I don't know if it's, we don't know at this time if it's warranted or not, but it is not maxing out the slider. It does not do an auto overclock. That's a different feature that AMD also has and already exists. So rage mode is increasing the power budget to the card and therefore increasing the frequency purely through the way boosting behavior works. With NVIDIA, that'd be called GPU boost, some version, and with AMD, it's the same type of thing. So this is not an auto OC. It is not increasing the memory speed. It is not affecting the memory timings, and our understanding is that it's not changing the voltage states except maybe to increase it. And so the power limited increase should be really the only thing that's happening here. To give you an idea of what this means, again, boosting on GPUs, AMD and NVIDIA alike, is contingent upon power, often first, and then thermals is often second, depending on the cooler. Then you get into voltage. So lifting the power budget will increase the frequency just completely alone, assuming thermals remain the same. And because of that, rage mode also increases the aggression of the fan curve. So the fans will ramp a bit harder, presumably to counter the temperature increase on the GPU core, to bring it back down to at least the same so that the frequency will then boost, because it is not additionally thermally constrained and it is less power constrained, so you get higher clocks. Typically this will result on NVIDIA, at least because it's recent, we've been testing it, in a change of about 15 to maybe 30 megahertz in the absolute best scenarios without any user OC applied and purely working from a power budget increase. So you might see something similar from AMD's rage mode. And that aligns with what AMD is promising, which is roughly about a 1 to 2% improvement in performance with rage mode enabled. In other words, this isn't a feature you need to particularly worry yourself with, but you can still click it, I suppose, and get a slight increase. You can also do manual OC through the normal means, and we'll be working with that once the cards are out. We have some additional information too that's sparsely detailed at this point, but it's worth keeping an eye on some of these as more info comes out. One of them, AMD noted that it will be compatible with Microsoft's Direct Storage API. NVIDIA talked about this as well and talked about RTX IO and its versioning. And that should help speed up load times and scene loads. It's comparable in some ways to what PlayStation and what the consoles have been talking about this generation. AMD also talked about variable rate shading. It talked about mesh shaders, sampler feedback, and a couple of other things that we have no further information on beyond the word. So those are buzzwords that we'll need to revisit once the architecture day commences. Other architectural changes include top-level references in the slides to these items. Improved CU performance, not surprising really, improved clock gating, restructuring of the pipeline, reworked data paths, and overall performance per watt improvements. Actually, they focused a good deal on performance per watt, and comparing it to RDNA1, it sounds like the performance per watt should be significantly higher. So that'll be something we're interested in testing. We wanted to ask how this scales with an OC or with the lower end, but weren't really given an opportunity to get an answer for that at this time. Next up, AMD's DXR support. This is an important piece of the story because one, console's coming out soon with ray tracing hardware, and two, it's sort of the one primary feature out of all of the buckets of useful and semi-BS features that NVIDIA and AMD alike offer. Ray tracing is the one that we noticed last generation stood out as a point where some people would say, well, but NVIDIA has RTX, or, well, who cares about RTX? So, DXR. AMD's GPUs will include hardware ray tracing accelerators. They are known simply as RT accelerators. They do not have a branded marketing name like RTX, just RT accelerators. They will be compatible with Microsoft DXR. As a refresher, DXR is sort of the backbone to real-time ray tracing in video games at present. There are other ways to do it as well, but DXR is the main one. DXR 1.0 and 1.1 are both supported on AMD's RT accelerators, and anything that's custom RTX or proprietary, or in some cases Vulkan RT implementation like Quake 2, which is an RTX implementation via Vulkan, those won't work on AMD's hardware out of box and will require either a rewrite or dropping features or changing features. So it's not a clean way to transition things, and reminds us a bit of the introduction of some 3D shaders from decades ago, where you see certain cards have features like shadows and other ones don't. So this is a bit of a Wild West right now in terms of ray tracing support, what games will and won't work, and it won't be as simple as yes or no supports real-time ray tracing. It will include a bit more of who's real-time ray tracing and which features, if both of them. AMD did not present any competitive slides for ray tracing performance at now. We would assume that this is mostly due to compatibility with games that are currently on the market. We asked AMD about compatibility and asked AMD to name the games that it would be compatible with at launch. And when we asked this question, the preface to it to AMD was, the reason we're asking this is because when NVIDIA launched the RTX 20 series, we basically boiled them alive for having 55 to 60 days of no RTX games to go with their new RTX branded GPUs, where RTX was the biggest push of the product, and yet there was nothing in sight for a couple months. So that was the reason we were asking. The company said that there will be games supported at launch. It was able to give us that much. It did not particularly go into detail on it, although there was a slide in AMD's presentation naming Dirt 5 and a couple of other games, and whichever of those have DXR enabled at launch, those should work with the AMD cards. AMD also noted that there's one RT accelerator for each CU. It said that some APIs could have issues with early implementation, and the ray tracing accelerators handle ray intersections within the BVH structure, and AMD also claims that Infinity Cache will help with ray tracing performance because AMD says that, quote, a high percentage of the data can be stored in Infinity Cache. AMD also leaned on its console presence to note that developer adoption may be aided going forward by nature of being the supplier to consoles and therefore the supplier of RT hardware to those consoles. And just to clarify here, saying ray tracing in the context of this video, we are referring specifically to real-time ray tracing in things like video games, because basically everything out now supports just purely ray tracing, just a difference of what form. Like, is it just Blender, pre-rendered stuff, or are we talking real time? AMD also has a feature called Super Resolution. We didn't get any additional answers on how it works or what exactly it does. NVIDIA did the same thing in its announcement. So as we know it right now, Super Resolution can be kind of thought of as a counterpart to DLSS, but AMD was hesitant to make this comparison because it works differently. AMD said that Super Resolution will have a broader application. DLSS, if you haven't kept up with it, is processed from a ground truth super high resolution image or set of images produced by the game's developers and sent into a supercomputer at NVIDIA offices and then processed for making determinations as to how to upscale the image or supersize the image without a meaningful loss of quality as seen in DLSS 1. So that's the basics, but AMD says its Super Resolution will be more broad in application. We asked if it would require developers to send images into a supercomputer that only AMD has, obviously referencing NVIDIA, and that question got a slight laugh and no real answer. So we'll find out soon what that one does. That's going to be extremely difficult to work around with testing because now again, it's like the old days of 3D shaders before I was doing reviews, where you're starting to debate like, okay, we got to test more than FPS if the image comes out differently. Now you're getting into image quality analysis, and that's hard. So we'll see how it's all implemented. We'll probably have to do some benchmarks with DLSS on, Super Resolution on, and with both off, so we can try and level the playing field or enable both advantages. We'll figure it out as it comes time. All right, performance claims. We don't often show too many first-party slides for these, or at least don't focus on them too much, and we always recommend checking back for third-party reviews, whether that's ours or someone else's. Doesn't particularly matter, but just for your own sake, check back for third-party reviews. For now, though, we'll show a couple of them. AMD is currently claiming that its 6800 XT GPU will roughly match an RTX 3080 at 320 watts for the 3080, so that's roughly the FE model. This was when tested in 4K gaming specifically. AMD lost in a couple of cases and won in a couple of others. The company also presented a 1440p slide with the same games, showing similar wins and losses. These slides do not note the usage of Smart Access Memory or SAM, so this should be like for like. The EndNotes section in RX-550 indicates that testing was completed with a 5900X, but that SAM is not on, or at least it's not notated as on. This should mean that AMD has actually technically a little bit more headroom than shown here, assuming SAM works in these titles. For the RX 6800, AMD is positioning the GPU against the RTX 3070, but because it wasn't launched at the time of this news announcement, AMD instead compared it to the 2080 Ti. This is roughly around 3070 performance from our own testing from GN, so that's a reasonable comparison. One huge caveat here, AMD changed its testing from the previous chart. So now it's showing the 6800 except with SAM enabled, which should be that extra couple percent needed to pull ahead in Youngblood and Division 2. The 6800 is shown as equaling the 2080 Ti, therefore the 3070, or outperforming it in most instances at 4K. We'll skip a couple of the other charts and show AMD's 6900 XT. For whatever reason, AMD decided to enable both Rage Mode and Smart Access Memory for these, which is sort of strange considering it was fine doing without those in the 6800 XT benchmarks, but whatever. This makes the power tough to estimate at this point, and the power slider has been adjusted in extent which we don't know, so we can't make a call for efficiency. The 6900 XT is claimed with these items enabled to be roughly equivalent to the 3090, which is interesting as a potential XOC solution for multi-GPU, especially if more than two-way crossfire is supported. We'll try to find out what the plans are for that later though. AMD also spent a little bit of time talking about some features it's already launched in the past, but is refreshing or bringing new focus to. One of those is anti-lag. This came out a little while ago at this point. And anti-lag specifically, we are planning to benchmark once the cards are out now that we have methodology in place, and we've explored that methodology and detailed it in a lengthy video on the channel. So that is something we can finally really look at properly, but we'll save benchmarking it for when the 6000 series RX cards come out rather than looking backwards. So that'll be a follow-up piece. It talks about a couple of other image quality changes or features like cast, for example, which it showed previously, and generally provided updates to existing technologies that have been updated for this generation. As for drivers, the last point here, we tried to find out what AMD's response has been to driver concerns within the community for the 5000 series cards. Now, this gets tricky. We were able to replicate a number of driver issues much later after the launch of the RX 5700 XT and 5700, but we really had to try to replicate some of them, and that's because test environments, you're dealing with all pretty new components, and as you start going back to older operating systems that users often have, like really old operating systems and builds, or older CPUs and boards, it gets complex. So we didn't see a lot of driver issues initially in the 5000 series. We found a whole host of bugs in Wattman and the driver software, but it took a while for us to start running into black screens, crashes, BSODs, things like that a lot of people in the community complained about. Either way, the issues still happened. Whether or not we saw all of them, it's obviously, again, a complex thing to look at. And we asked AMD back at CES either this year or last year what its plans were for driver updates, and it remarked that it would be heavily focusing resources on driver updates. Our understanding from speaking with people at AMD is that it's currently all hands on deck for the Radeon drivers, and so presumably this should get some more focus on stability than some of the previous 5000 series drivers that came out. But we'll see how that develops. That's a tough one. We're gonna have to rely on the community a bit to fill us in on how things are working on your systems, because it's not reasonable for us to test every possible combination. So that's it for this one. That's AMD's announcements. We'll have more on the Ryzen 5000 series soon. AMD is launching those on November 5th. Reviews should probably be going up the same day. So we'll be looking at the Ryzen 5000 series CPUs ASAP, and then the RDNA stuff after that. Again, mid-November and early December for the launches on these, with the 6900 XT coming out just before Cyberpunk 2077, now that it's been delayed to December 10th. That's it for this one. Thanks for watching. Subscribe for more. Go to store.gamersnexus.net to help us out directly, and we'll see you all next time.